Well, good morning everyone here, and welcome back. It's Tuesday or Wednesday, depending on the block day, and next time you come, I will be here, so hope you're enjoying your time so far. As far as the quizzes from yesterday went, well, I haven't graded them, of course, so I'll show you maybe on Friday. Today, though, we are going to be talking about a lesson. There's a lot of things we're going to be doing here today. We're going to be talking about a lesson, we're going to do some homework, and I think we got a little matching game we're going to be doing, and then quite possibly, if you're lucky and you behave, you might be going to the lab to do some math games on the computers. So, listen up, take out your notes. There should be some notes being passed out right now, or have already been passed out, about inverses is our topic today. Inverses. Woo! Sounds like fun. You guys ready? Oh, let's go. Alright, so first of all, before we get into inverses, something you need to remember from before is that function notation reads as f of x. Do you remember that? F of x. Alright, equals 2x plus 5. What is f of x really? What is the real thing that we put f of x in for, actually? Well, the answer is y. We could really rewrite this as y equals 2x plus 5. This would be our normal form, okay? This is function notation because we're saying it's a function. That's what the F stands for. But normally, we could just write it as y equals 2x plus 5, and I think everybody would like to graph it a lot better if it was y equals. So, we're going to do a lot of conversions from f of x to y. Just remember, f of x means y. You got it in your notes? Can you see that okay? Hopefully. Hopefully you can see that. Okay. I'm hoping. Next. Alright. What does inverse mean? We've seen it before. We've seen it in our properties. I don't know if you remember commutative, associative, distributive, inverse, zero. We've seen all those. But what does inverse really mean? Well, I'm going to show you. Got my jacket here, a little sweater. What is the inverse of this? Well, I'm going to take it, pull out the arms. Well, this is nice. I don't have anybody like talking. It's really nice. Alright, I'm going to take it, I'm going to pull it inside out. I don't know if you can tell that, but there's the collar. This is all inside out. Now, I'm wearing the sweater. I'm using the sweater inversely. It's the opposite way. And that's right, I'm going to teach the whole lesson inverse. I'm going to have my whole sweater inverted. You guys ever heard that word before? Inverted? They might, maybe some of you guys might have seen some tricks that say, oh man, he did an inverted backflip, or, you know, check out that ollie, it was an inverted, or whatever. Invert. Not extrovert, but an invert, okay? Inverse. What does it mean? It means to kind of flip it around. Make it the opposite. Alright, this is kind of, well, I mean, I don't know if you can see. There's my zipper. It's inside out. It doesn't actually look too bad. I kind of like this look. Anyways, so remember their inverse properties. Inverse properties. Well, what's the inverse of positive? What's the inverse of positive? We do this all the time. Well, it's a negative. Right? It's a negative. That's how we do inverse of positive. What's the inverse of a negative? Well, we got to flip it around. What's the inverse of a negative? Positive 7, right? That's the inverse. Here's another one. What's the inverse of a multiplication symbol? Well, what's the inverse of multiplication? Division. Right? Division's the inverse. And what's the inverse of division? Well, in that case, that would be multiplication. Alright, inverse. It means like the opposite. No, it's not necessarily the opposite. It's just kind of flipping it around. Maybe it's inside out. Inside out is not always the opposite. But we'll get into that a little bit better. Alright, so here we go. What is the inverse now? Not just of an operation. We just found out the inverse of operations. So inverse of positive is a negative, inverse of negative is positive, and so on. But what if I wanted to find the inverse of this? That's an equation. That's a line. I could graph that baby if I wanted to, but I don't want to right now. So how do I make the inverse of this? Well, I need to put it inside out. So here's how you do inverse. Pretty simple. All you do for inverse is you switch your x and your y. And that's going to do it. You guys ready? So now instead of y equals, it's going to be x equals 2y plus 3. That's the inverse. I just switched it around. Now the only problem with this, now like I said, this is the inverse. Switch my x with my y. The only bad problem about this is that I don't like y with all this rot around it. Remember, if I want to graph something, don't I want to graph something when it's y equals, I don't even know where I have that. Don't I want to graph it when it's y equals something? That's how I graph stuff. I don't graph stuff with x equals. So once I've done the inverse, I just did the inverse here, I like to finalize it by getting y by itself. Alright, and this is just like taking something from standard notation into slope-intercept form. Okay, so here's how I'm going to do it. I'm going to minus the 3. Wouldn't you agree? Plus 3 and negative 3, that's going to cancel. So I have to minus 3 over here. This is going to leave me with x minus 3 equals 2 y's. Does that all make sense? I'm going to draw the line so you guys can tell the difference. Those are wiped out. Okay, then how do I get rid of this 2 here? It's being multiplied. Well, I got to do the inverse operation actually. The inverse operation is dividing by 2. So that means I divide everything over here by 2. And I am left with y equals, this is really a 1, would you agree? So it's going to be 1/2 x minus 3/2. Okay? That's the inverse. Some of you might be like, I hate that look. Why do you have y all by itself over here? Well, sure, why? Why not? Right at y equals, then you go 1/2 x minus 3/2. If you are really, truly that picky, you could do it like that, but it's fine if you got y over there. That's the inverse. So, once again, how do we find the inverse? We just take our x and our y and we switch them. Guys, that's our lesson today. We switch our x and our y. It's not that bad. It's not bad at all. Just to switch the x and the y. Okay? And then, it's just like what we've been talking about last week and earlier, how to get y then by itself. Alright, here's another situation, alright? Now, here's where it gets a little ugly, and you're going to see in your homework today. All you get is this. Well, remember, first of all, what does f of x actually mean? We talked about it right at the beginning. It's y. So, I'm just going to rewrite this. I haven't done anything yet. I'm just rewriting it the way I like it. Alright, and I like it y instead of f of x. So make sure you've got y there. Alright, then I'm going to do my inverse. You guys ready? Inverse. X equals 6y minus 5. Whew! Oh man, I think I pulled something. That was tough, wasn't it? All I did was I took my x and my y and I switched them around. That's the inverse. Inside out, baby. By the way, I think that's a Pixar movie coming up. I think Inside Out. Alright, anyways, now just because we're picky in math, we're going to get y by itself now. So how do I get y by itself? I start with the thing furthest, and I add 5. Add 5. That's going to cancel, and I'm left with 6y equals x plus 5. You guys ready? Continue on? We all good? Okay. How do I get rid of that 6? Divide by 6. Gotta divide that by 6, and I gotta divide that by 6. Got y equals, I remember that's a 1, right? So it's actually 1/6 x plus 5/6 equals y. The one that I want. You guys good? Can everybody see that all right? Okay. It's that easy. Okay. Switching one more thing. Alright, sorry. My camera shuts off after every 10 minutes. So we're going to finish this in 10 minutes. You guys ready? Here we go. Graph it. Actually, wait, I'm going to do it in blue. I'm going to write this as y equals 4x minus 2. Haven't done anything different, just rewrote f of x as y. Okay? Then I'm going to graph the normal function. What does it normally look like? Alright? It's going to be negative 2. Start off at negative 2. Then it's going to go up 4 over 1. 1, 2, 3, 4 over 1. 1. Kapoosh. Alright, now I'm going to take that and go up 4 over 1 more time and graph the line. Alright, so that is my normal function. Now, graph the inverse. We're going to do this in red. Alright, we're going to graph the inverse in red. So first off, I'm going to take and switch my x and my y. So I've got now x equals 4y minus 2. There's the inverse. Graph that out. Well, I don't know where to start. You've got to get y by itself, right? Okay, now this I'm actually going to move around the y here, but we'll go plus 2, plus 2. That's gone. And I'm left with 4y equals x plus 2. Alright? We're not doing rocket science here yet. Then how do I get rid of the 4? I divide the 4. Divide the 4 here. Divide the 4 there. Alright, this is where the fun gets. Alright. So I have y equals 1/2 plus 1/4 x. Alright, so I'm going to rewrite this. Y equals 1/4 x plus 1/2. Now, one more thing that I haven't mentioned yet. They usually like to, inverses, the final ending, they would probably not have that y because what did they start off with? They said f of x. So they probably write f of x again. But then they put this little negative 1 at the top, meaning that's the inverse. So they put a little negative 1 up there. It's just fancy writing. But for our being right now, we're just going to go y. Alright? So how do I graph this? Well, where do I start? I start at 1/2. This is tough. This is going to be really tough. Then I go up 1. Well, up 1 from here is up to there, halfway there. And then I go over 4. So 1, 2, 3, 4. You got that? Okay. Now we're not exactly on any of the hash marks because we're like right between them. I think we should be able to handle that. Just going to erase my little jiggies. Alright. So what does our function look like? Well, Looks like that. Now here's the kicker. You guys ready? Because we switched our x and our y, it's like these things just rotated. So you see how this was up? Now we switched our x and our y, and now it's down. See how far it is away roughly here? It's about the same distance as it was away from up here. Okay? So our inverse. Basically, if you wanted to, they always say you could take a mirror. It's like a mirror image going up like this. And if we just had that as a mirror, this is like the reflection. So this is the normal, and then the function, or the inverse reflects itself down there. So if that was like the mirror, and you're looking in, you would see it kind of over there. Alright. Homework. You guys ready? Find the inverse of each function. We're going to do number 1. We'll do one of the... Alright, I ran out of space again. So, anyways, here we go. We're going to do homework for the day. We're going to go through a couple examples, and then it's your turn, your time to shine. Here we go, number 1. It says find the inverse of each function. Well, remember, f of x is actually y equals 3/5 x. I haven't done anything, I just rewrote it the way I like it. I like y instead of f of x. Alright, now, here's where I'm going to do the inverse. Remember, you switch your x with your y. So really, I'm going to write this as x equals 3/5 y. Now, because I'm a little finicky, I like y always by itself. That's how math always is. You got to get y by itself. So, how do I get rid of this 3/5? Many of you probably have forgotten this. How do I get rid of a fraction? It's being multiplied. How do I get rid of a fraction? Would you agree that if I took the reciprocal and did 5/3, and multiplied this by the reciprocal 5/3, would you agree that that 5 is going to cancel out with that 5? And this 3 is going to cancel out with that 3. So now, all I've got over here left is y equals 5/3 x, right? That's the answer. I'm going to write this as y equals 5/3 x. And that, my dear, is the inverse. You might want to, I'm not going to be extremely picky on this right now, but instead of y, you might want to put this to f of x. Then -1. Remember that -1 means it's the inverse. Since that's the way they gave it to us, f of x, we might want to rewrite it as f of x to -1. That means inverse. Let's do one more of these, alright? Y equals x minus 1. Now I'm going to switch it around, do the inverse. So now I got x equals y minus 1. Alright, get y by itself, so add 1, and that's gone. I'm left with y equals x plus 1. And then, for safety's sake, I might write that as f of x -1 equals x plus 1. Remember that -1 exponent, all it is just for telling me it's inverse. Okay? We doing alright so far? I hope you guys can see this alright. So you're going to have to do that on 4 other ones. And I got a couple graphs. You guys ready for these graphs? Do one graph for you. Let's do number 7. So once again, I'm going to do the same thing. I'm going to write this as y equals -1/5 x instead of f of x. Now I'm going to do the inverse, switch them around. So it's x equals -1/5 y. Alright, now how do I get rid of 1/5? I just told you. How do I get rid of a fraction? Well, I have to multiply by the reciprocal. So I'm going to multiply this by 5/1, and I'm going to make that negative. So I got to multiply this by 5/1. I got to make that a negative. Now, would you agree that's going to cancel? That's going to cancel, and I'm left with y equals -5. Wouldn't you agree that's a -5? x. That's the inverse. Alright? Maybe you guys can't even see this, it might be too low. I don't know. We're going to go with it. So the first one I'm going to graph, I'm going to graph this one. This is the normal one. Y equals negative 1/5 x. Starts at 0, goes down 1 over 5. Or up 1, back 5. Alright, so that is the normal function. The inverse function now. The inverse function is this bad boy. And this bad boy, well, remember I could also write it as this, right? Y equals negative 5. Well, where does this one start? I'm going to graph this one in green. This one starts at 0, so I'm going to start it at 0. But this one actually goes down 5 over 1. So it's going to go 1, 2, 3, 4, 5 over 1. Or it could go up 5, back 1. Alright. Okay? And then just for kicks and giggles, does that look like it's a reflection of this? Like if this was the mirror? Does this look like it would be the reflection of that, or that's the reflection of that? I think so. You don't need to put that in there, just so you know, but just to double check it. It's always good to see. Alright, there you go, number 8, and you're off to your races. Now, you might want to pause this video right now and wait till all the homework is done, and I want this collected. Alright, I want this whole thing collected with your notes and your names on there. Pause it because I'm going to move on to our next activity after the homework. So, pause. Alright, our matching activity. Everybody's going to get, first of all, break into groups of 2. So there should be everybody at a desk with 2. If you want to work by yourself, I think I've got enough for working by yourself. So, work in groups of 2 at a desk. You're probably going to want to put your desks together, spread out all the pieces of paper. We're playing matching. And basically, I believe there's 14 graphs, and there's 14 equations. Alright? And so you have to match which graph goes with the correct equation. Now here's a couple hints for you. Alright, here's a couple hints for you. First of all, let's say I'm looking at graph 8. I think this is graph 8. Okay, graph 8. First of all, I know this is going down, right? So it's got a negative slope. So right away, I might want to separate my equations over here with negative slopes and positive slopes. Because we know automatically I'm looking for one that's got a negative. So right away, I have 3 choices over here. Right away, I know it's not F, because this is a positive slope. Remember, that's a positive 1. I know F is not a choice. Alright, this is a negative slope and this one's a negative slope. Then the other thing I want to look for is, hey, where does it cross? Okay, where is my y-intercept? Looks to me like it crosses at 5. Okay, so as I look through, I look for negative slopes, and then I look where it crosses. This can't be. This one crosses at 4. So I'm looking and I see, and I might find this one. It's called I. Alright, and, sorry, there we go. I'll look at I. You say, boy, that looks pretty good. Remember, the slope is negative 1 over 1. So does this look like it goes down 1 over 1? Down 1 over 1, down 1 over 1, down 1 over 1. Does it seem to match? It does. So, on our little sheet, okay, you're going to have your name, and I would go to graph 8. So this is the graph. Graph 8 matches with equation I. Alright, so these are the graphs. Okay, and then I have to put in what equation goes with it. So I'd say 8 goes with I. You guys kind of got the hang of it, but like I said, I would separate our negative slopes from our positive slopes, and right away I think we've already narrowed it down to only like 7 choices, and then look for those intercepts. I think this should go pretty fast, okay? Alright, you guys ready? And go!